mutually exclusive or inclusive. There are two types of events when dealing with probability. Mutually exclusive events are events that have nothing in common. There's no overlap or no event that happens at the same time. Inclusive events, something in common. When you have two events that are inclusive, it means you can have one outcome be part of two different groups, so they have an event or something in common. First problem we'll look at is rolling a 3 or an odd number on a die. The two events, first event is rolling a 3, the second event is rolling a odd number. To determine if they're mutually exclusive or inclusive, you want to see if they have anything in common or any overlap. For example, if you roll a 3 is an odd number, so rolling a 3 would be part of both groups, which means they have something in common, so these events would be inclusive. Inclusive again means you have something in common, there's an overlap, the number 3 would be in both groups. Second question, and last question for the section, choosing one boy and one girl in the class. The two events are choosing one boy, and the second event's choosing one girl. Since boys and girls are separate categories, there is no overlap or nothing in common. Nothing in common, these events would be mutually exclusive. Mutually exclusive again, the events are completely separate, so they have nothing in common and there is no overlap. Probability of mutually exclusive events. If you have two events which are mutually exclusive and do not have anything in common, the probability of the two events, probability of event A happening or event B, would be the addition property. You can take the two probabilities and add those together. So the probability of A or B would be the probability of A plus the probability of B. We'll use this in the next example where Jesse will be choosing 3 friends and 5 are boys and 3 are girls. First problem we'll solve using the word problem is to find the probability that we will have 2 boys selected or 2 girls selected. Again, 2 different events, 2 boys or 2 girls, mutually exclusive, since if we have 2 boys, we cannot have 2 girls, and they would not have anything in common. The addition property, we can find the probability of 2 boys and add to that the probability of 2 girls. The first probability of 2 boys would be a combination. Anytime you're picking multiple events and the order does not matter if the boy is picked first or last, as long as we have 2 boys, we'll do a combination. The first number in the combination again is the total amount. In the word problem we have 5 boys to choose from, and again we want to find 2 of those to be boys, so the combination will be 5, 2. Multiplying that by the second choice, if we're picking 2 boys, in that same scenario we'll end up picking 1 girl. So we'll have a second combination for 2 boys, and we'll have a combination for having 1 girl from the 3 that we pick. The amount of girls would be 3, and if we pick 2 boys, we'll have a single girl we'll be picking. So the number of ways to pick 2 boys would be combination 5, 2 for the 2 boys, and combination 3, 1 for the 1 girl in the 2 boys scenario. And again, probabilities will make fractions. The combination for the denominators, the total number of ways you can pick 3 people. There's 8 people to choose from, 5 boys and 3 girls, and we'll be choosing 3 of those, so we have 2 boys and 1 girl. The second fraction will add to that. First fraction was probability of 2 boys. The second fraction will be the probability of 2 girls. Again, a combination, since the order does not matter, on the number of girls that we select. There's 3 girls total, and again we want to pick 2 of those. So combination 3, 2 is the number of ways to pick 2 girls. Since we're picking 2 girls, the one left over has to be a boy. So multiplying by the number of ways to pick a single boy, there's 5 boys altogether, and we're picking a single one. So the number of ways to pick 2 girls would be combination 3, 2 for the 2 girls times the combination for the 1 extra boy, 5, 1. The denominator will be the same as the first fraction, 8 people altogether, and we're picking 3, so the total number of ways to pick 3 people will be combination 8, 3. Solving from here, we can change these 2 factorials. Combination 5, 2 would be 5 factorial divided by, subtracting the 2 numbers, 5 minus 2 would be 3 factorial, and combination have the extra factorial on the bottom, which is 2 factorial. Multiplying by the second combination, 3, 1. 3 factorial would be the numerator. Subtracting 3 minus 1 would be 2 factorial, and the extra factorial for combination would be 1 factorial. For the denominator, combination 8, 3. 8 factorial will be the numerator, divided by 8 minus 3 will be 5 factorial, and the extra factorial, 3 factorial in the denominator. The second fraction will add to that for the 2 girls. Combination 3, 2 would be 3 factorial, divided by, subtracting them would be 1 factorial, and the extra 2 comes down for 2 factorial. Times combination 5, 1 would be 5 factorial, subtracting would be 4 factorial, and the extra 1 factorial. The denominator, combination 8, 3, again is the same denominator, 8 factorial divided by 5 factorial and 3 factorial. Solving from here, we can write out the factorials and cancel the numbers in common. 5 factorial would be 5, 4, 3, 2, 1, divided by 3 factorial, 3, 2, 1, and 2 factorial, 2, 1, times 3 factorial would be 3, 2, 1, 2 factorial would be 2 and 1, and 1 factorial would be 1. Divided by, again, our denominator, 8 factorial, which again would be 8, 7, 6, 5, 4, 3, 2, 1. And the denominator for that one, 5 factorial, 5, 4, 3, 2, 1, and 3 factorial, 3, 2, 1. Adding to that the second fraction, 3 factorial would be 3, 2, 1. 1 factorial would be 1, and 2 factorial would be 2 and 1. Times 5 factorial, 5, 4, 3, 2, 1, over 4 factorial, 4, 3, 2, 1, and a single 1 factorial, which would be 1. And the denominator, again, both the same, 8 factorial, 5 factorial, and 3 factorial. From here, we can cancel the numbers in common. The first fraction, 3, 2, 1, will cancel out. And if you divide by 2, we'll be left with a 5 and 2 in the numerator. Times the second fraction, 2 and 1 will cancel, and the single 1 we can ignore, so we'll be left with a 3 for the second fraction. For the denominator, 5, 4, 3, 2, 1 will cancel. 3 times 2 would be 6, so we'd cancel the 6 and the 3 times 2. And the 1 again we can ignore, so we'll be left with 8 and 7. The second fraction, 2 and 1 we can cancel, and the single 1 we can ignore, so we're left with a 3. Times 4, 3, 2, 1 cancels. The 1 we can ignore, so we're left with a single 5. And the denominator, just like the first fraction, 5 through 1 cancels, and the 6 and the 3 and the 2 cancels, and the 1 we can ignore. Rewriting the numbers, we'll have 5 and 2 left in the first fraction. Multiplying 5 times 2 would be 10, times the second fraction we have a 3 left. For the denominator we have 8 times 7, which would be 56. Adding to that the second fraction, we have a 3 in the first fraction, a 5 in the second fraction, multiplying those. And again, the denominator, we have 8 times 7, which would be 56. And again, the denominator, we have 8 times 7, which would be 56. Simplifying, 10 times 3 will have 30 over 56, plus 3 times 5 would be 15 over 56. Adding those together, we'll have 45 over 56. This fraction cannot be reduced, so our final answer, 45 over 56, which again is the probability of picking 2 boys or 2 girls. Probability of 2 boys is 30 over 56. Probability of 2 girls is 15 over 56. So the total probability, 45 out of 56. Last question for the section. Having the same word problem, we'll find the probability we'll have at least 2 girls. At least 2 girls means we could have 2 girls or more. Since we're picking 3 people, we can either have 2 girls or 3 girls. So the first fraction we'll set up for the probability is the probability of 2 girls. Again, a combination. The number of girls total would be 3. And if we're picking 2 girls, that would be 3 comma 2. Multiplying a second combination. If we pick 2 girls, that means the other one has to be a boy. Combination 5 total boys, and we'll be picking 1. So the number of ways to pick 2 girls would be combination 3 comma 2 times combination 5 comma 1. Setting the fraction up again, the combination. Same denominator as we had before. There's 8 total people, and we're picking 3 people from those 8. So the total number of possibilities, combination 8 comma 3. Adding to this, the second outcome, at least 2 girls means 2 girls or 3 girls. So the second fraction, a combination, will be picking 3 girls. There's 3 girls total, and we want to choose all 3 of those. So combination would be 3 comma 3. Since we're picking 3 girls, there's no boys left to pick, so there's no other combination to multiply by. 3 girls would just be 3 comma 3. And the denominator, combination 8 comma 3. 8 total people and 3 girls we're picking. Looking back at the previous question, this first fraction, the probability or chance of 2 girls, 3 comma 2, 5 comma 1, and 8 comma 3. We actually solved that. That was the second fraction of the previous question, and that came out to be 15 over 56. So the first entire fraction, same work we had before, 15 over 56. We'll add to that the new fraction, combination 3 comma 3 over combination 8 comma 3. Combination 3 comma 3 would be 3 factorial divided by subtracting the numbers 0 factorial and the extra 3 on the bottom, 3 factorial. And a fraction line, combination 8 comma 3. Again, you can write out the factorials, which would be 8 factorial over subtracting 5 factorial and 3 factorial. Solving from here, the 3 factorial would be 3 times 2 times 1. Definition of 0 factorial, since we cannot multiply by numbers less than 0 and we're already below 1, the definition of 0 factorial is equal to 1. So anytime you have 0 factorial by definition equals 1. And 3 factorial will have 3, 2, and 1. Divided by 8 factorial, 5 factorial, and 3 factorial. Again, this one we did in the previous problem. It's the same answer, same denominator, which would be 56. Simplifying the second fraction, 3 to 1 will cancel. The 1 we can cancel. In this fraction, all the numbers divide out. Keep in mind when you're dividing, 3 divided by 3, 2 divided by 2, or 1 divided by 1. The answer would be 1 when we're dividing, or if everything cancels out, we'll be left with 1. Our first fraction again from the previous problem, 15 over 56. Adding to that the second fraction, we have a single 1 left over 56. So the probability of 3 girls is 1 over 56. Probability of 2 girls is 15 over 56. Adding those together, we'll have 16 over 56. Dividing those out or reducing, you can divide each number by 8. So our final answer would be 2 over 7. So the probability of picking at least 2 girls, which is either 2 girls or 3 girls, the probability would be 2 over 7.